Alright, so we just got done graphing sine. Today we're going to graph cosine. And what you're going to see is there's a lot of similarities between what we're doing today and what we did on graphing sine. In fact, we're going to start out with kind of a remembering of what does sine look like. Sine looks like a wave, right? It started at 0, 0 and it was up, down, down, and up, and that's what it looked like. Now what you're going to see today is cosine is what I like to call a ditch, okay? Because it looks like a ditch. It has the shape where it kind of looks like this, okay? That's not as accurate as I'd like because I hit this thing on the way up, but you get the idea of what I'm saying. Matter of fact, let's do this in degrees just like I did before. And we know that this is 0 degrees, 90 degrees, 180, 270, and then back to 360. And we know the point values here, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And today we're going to use the cosine values. If you don't remember, cosine is the x values at all of these points. And we're going to still do the same thing, 4 bars, one at the end, one in the middle, one in the middle of that, one in the middle of that. And my amplitude is still 1. The period for a regular sine graph, just y equals cosine of x, is still 2 pi. Because we're still going to find the period the same way. You can see that all the way down at the bottom where it says 2 pi over b. And 2 pi over 1 is still 2 pi. So the period still goes at the end. Half the period goes here. And here's how it's going to work. At 0 degrees, the x value is 1. So I start up here. At 90 degrees, the x value is 0. Sorry, this is not pi, and this is not 2. I totally messed that up. This is 180 degrees. We're going to graph the radians one down here. This is 360 degrees. So the period is 360 degrees. 0. At 180 degrees, it's negative 1. At 270, it's 0 again. And at 360, it's 1 again. And so it looks like a ditch. Okay. Now, if we graph it in radians, remember what these radians values are. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm not even going to write the point values in there because we already did that up here. And I'm just going to use the same x values. So my, again, is 1 and negative 1. My amplitude is 1. At the end, well, 360 pi over 180 is 2 pi. So that's my period here. In the middle is pi. This is what I was trying to do before. 3 pi over 2. Now remember, I'm only making you label the end and the middle, so you don't have to have these other values, but I put them in there anyway. And it's the same thing. It starts at 1, down, down, up, and up. Down, down, up, and up. Yeah, it doesn't have the same ring as the other one, but the shape you should see is a ditch. Okay. Now, what am I trying to accomplish down here where it says, how are these graphs different? And how are they the same? Well, if you were to extend this, look here. That looks like cosine. If I were to keep going with this and bring it down to here, well, that looks like sine just shifted over, right? They actually kind of look like, I'm going to kind of write it here, what I'm trying to get you to look at is that it looks like same graph translated. Translations are something that you did in geometry, just means shifted over pi over 2 in x directions. Like if I were to just move it over a little bit, it'd be the other graph. If I were to move it over a little bit, it'd be the other graph. And that is the case. We still have the same rules as sine. Amplitude is the absolute value of a. Period is 2 pi over b. So let's look at this first one. By now we should know a is the number in front because these are in the form. Let's write it down. Y equals a cosine of bx. Okay, I'm going to change this theta to an x. They mean the same thing. Okay. So what's my a here? My a is the number in front. When there's nothing in front, remember it's not 0 because that would make it all 0. It's 1. And then my amplitude then is 1. What's my b? The b is the number in front of x. A lot of people are putting 4x here. It's just 4. It's the number in front of the x. Therefore my period, well remember, we just go 2 pi divided by b. If my b is 4, then I just simplify this. 2 goes out of there once, 2 goes out of there 2. It's pi over 2. Remember how we graph these? At the end is the period. The amplitude goes here, 1 and -1. I'm going to put my 4 bars here. Half of pi over 2. What I keep saying, and it's still the same way in this graph, is times 2 by 2 to get pi over 4. Half of a $half is a quarter. Makes sense. And then it just is all the same. Starts at 1, then 0, -1, 0, 1. Connect your dots. They all look the same, except same thing as cosine when I have a negative. Well, guess what it does? What did it do for sine? For sine, it just flipped the graph. For cosine, it still flips the graph. Okay. So let's do the second one together. This would be one where in class I'm going to do it kind of with you. A is -2 here, but what's the amplitude? Remember, the amplitude is measuring distance. And the amplitude from top to bottom, 1 minus -1 divided by 2 would give me 1. Here, I'd have 2 and -2. 2 minus -2 is 4. Divided by 2 still gives me 2. Remember, it's distance. It's always positive, and that's where this absolute value thing comes in. B here, remember this is 1x over 3, which is 1/3 x. So B is 1/3. And the period, remember whenever we get a fraction, it's divided by. So it'd be keep it, change it, flip it, and multiply across to get 6 pi. That goes at the end. And do the rest of them here. Half of that is, of course, 3 pi. Now, here's the thing. If I were to plug in, well, let's just look at it, 3 pi, okay, into right there. I'd get -2 times cosine of 3 pi over 3, which is -2 times cosine of pi, because those would just cancel. And cosine of pi, if I go all the way up above, we said cosine of pi is -1. Okay, so with that being said, this becomes -2 times -1, which is 2. So at 3 pi, the value is up here. What about at 0? If I plug 0 in here, 0 over 3 is 0. Cosine of 0, look up above at our graph, cosine of 0 is 1. Okay, so that would end up being -2 times 1 for this point, which is -2 down here. Well, then you can obviously see, instead of starting up here, we start down here. The zeros are still here and here, and my last point is here. And instead of a ditch, it's a hill. Okay, so not only does it flip the graph, it becomes a quote-unquote hill. Okay? That's it. The graphs all look the same, except for when it's negative, it just flips it. Okay? Let's go to the next page. What I want you to do is join me on the next page. I don't have an example for you to try on your own here. We're just going to come to the top of the next page here. And you're going to see problems again, very similar to what we did yesterday. What I need to do is graph it. I'm assuming right here that A is greater than 0, so all of my graphs are going to look like ditches. And I'm going to put 4 bars and 2 bars in the y direction. I'm going to go do that in all of these problems at the same time, just to get everything lined up. Okay, what I know is that the period goes at the end. In all of these problems, it shows me the period. So this is pi over 4, 1/4 pi, and this is 6 pi. I know what half of these are. That's 2 pi there. That's pi over, remember, times that by 2 to get 8. 6 pi, half of that is 3 pi. Now, my amplitude is given 2, -2, 1/2, -1/2, 3.5, -3.5, and they all look the same. They all look like ditches. They all are the same thing. So it goes here, down, down, up and up. Connect your dots. Starts here, down, down, up and up. Starts here, down, down, up and up. They all look the same. Okay, and again, it's because A is greater than 0. If I didn't know that, maybe some of them are hills, but I don't. Now again, we're going to start these off, and today we're dealing with cosine. So it's 2 cosine, because the A always goes in front, 1/2 cosine, and 3.5 cosine. Okay? Now, what I would do in class is I would do this one, and then I'd have you guys try both of the next two. So how do I find the B? remember that the period is 2 pi over b. So if I replace this period with the period, which is 4 pi, I can just, like yesterday, set them equal to each other. If I have a number like that, I put it over 1 and cross multiply. 4 pi b equals 2 pi. Divide both by 4 pi. The pi's cancel in both cases. The 4's cancel here. B is reduce the fraction 1/2 x. And that's my answer. See if you can do the b on each of these. Press pause. Try that. I'm going to write it in. Now we said yesterday that whatever I get here, its reciprocal is b. It's always working that way. The reciprocal of 1/8 is 8. The reciprocal of 3 is 1/3. The reciprocal of 2 is 1/2, and so on. So I can kind of check myself there to make sure not only do I have this right, but do I have that right in the middle. Okay? Because some people want to call this at pi over 2. Because they're thinking half of 4 is 2. Yes, but half of a fourth, half of a quarter would be like 12.5 cents, which is 1/8. Yeah, that's not really applicable, but you get what I'm trying to say, I hope. Down below, when I'm writing these equations down below here, what I need to do is I need to write in the amplitude. Well, the amplitude, hopefully you know, goes from the top of the hill to the bottom of the hill. So this starts at 3, goes down to 3. 3 minus -3 divided by 2, still the same rule, 6 over 2, is 3. My period, however, now remember a lot of them start here. So if it starts here, what does that mean? That means I'm going to have -3 cosine in here. Okay? Because it's not starting at the top, it's starting at the bottom. We talked about that on the previous page, the last problem. Now, the period starts on the y-axis, goes up, up, down, and down, and goes to there. What is the distance between those 2 points? Well, look at it, it's lining up. A lot of you want to say it's 3, but that's not what the measurements are. They're going by pi's, and the period here is indeed pi. Again, how do I find b? Well, we just did a ton of those problems up above. You set the period equal to 2 pi over b, cross multiply, 2 pi equals b pi, and solve. B equals 2, and there's my answer. Done. Okay. Now number 2, very similar. Try it on your own and come back to it. Now again, you're going to get a pi that comes in your answer here, but press pause, try it once, come back and check your work. The period from where it starts to where it starts again is 8. I can start right away. I started up top, so I can have +2 cosine. Set my period equal to 2 pi over b, cross multiply, 8b equals 2 pi, divide by 8, these cancel, and these cancel, and so I get 1 pi over 4. So pi over 4x. And that's how I do that. For the next problems, you have to use a calculator for, and I left my calculator in the other room. So just press pause, or actually fast forward, because I literally have to run into the other room and get my calculator. Okay, I'm back. Sorry about that. But I want you to be able to see, I want to show you in the calculator what we're going to do here for these problems at the bottom. We are going to, not your iPad, this is stupid, my bad. We're going to use graphing calculators here. Okay? And to solve this equation, what I'm going to do is I'm going to plug them both into the calculator. Here's how you do it. Okay? I got to turn it on, obviously. Clear. Let me zoom you in a little bit, and I haven't zoomed yet on this ever, so bear with me here. Okay. So you can see what's going on here. I'm going to press y equals, this button right here. Clear everything out you got. Okay. because other people have been using this, and you're going to type in the left side of the equation. Okay, the left side on number 1 says 3 cosine of 2t. And you can just use x for that. And x is this little button that says right there x, t. That stands for all the variables. And I'm just going to close my parentheses. Now I have 3 times log of, or cosine of 2x. I'm going to go down. So this little button here, down. And I'm going to type in the other side. The other side says negative 2. And I'm just going to press the graph button. And what happens here is you get a straight line. The problem is I need to make sure that my graph is in radians. Okay? If you get straight lines, you don't get a curve that we want. So what I'm going to do here is this little button right here says mode, right next to the second button, press mode. That comes up. Make sure you go down to degrees, and where it says radians, you need to press enter so it slips into radians. Now I can do the same thing. Go to y equals, make sure my graphs are good, and go to graph. Now you can see what we've come to expect out of these graphs. Cosine starts, again, up here, down, down, up, and up. And you can see where they intersect. Now we've done some work with this in terms of how to find the points of intersection. Remember what we do? We did a whole lesson on this. We go second, trace, and that calculate options come up. Again, what I'm trying to find here is the point of intersection between 0 and 2 pi, which means I'm trying to find it between, matter of fact, I'm going to go back to here, between 0 and 2 pi is between 0 and 6.28 is where I'm trying to find all the values where they intersect. So I'm going to intersect, so press 5, and it comes here. And remember, what you got to do is get close to the point. Be careful, that's the x-axis. That's real close to the point of intersection between the curve and this straight line down here. So I'm going to go down to where it's close. I'm going to press enter, enter, enter. And it gives me the value. I know negative 2 is the answer. What I want is the 1.15. And I say round everything to the nearest hundredth, which means to 2 decimal places. Okay. So, let me go over here a second. For this problem, at t equals 1.15. That's my first answer. I'm going to go back here. I'm going to do the same thing all over again. I'm going to go to second, trace, I'm going to press 5, and I'm going to go to the next closest point. Okay, the next closest point, I'm going to go over. There I can see it's real close, the cursor is real close to both the intersections here. And I'm just going to press enter, enter, enter. And it gives me the next value, 1.99. Okay, I'm going to go write that on my paper too. Okay, 1.99. I'm going to show you the end result here in a second, but then I'm going to do it again. Okay, I've got another point of intersection there, and there, and there, and there. So let's just keep going. Second, calc, intersect. I'm going to, again, bring the cursor so that it's real close to the points of intersection here. And I'm going to go enter, enter, enter. There's my next value, 4.29. And on the next one, again, second, trace, 5. I'm going to go over to the next point, enter, 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 and I get 5.13. Now here's the thing, I'm going to do it one more time, and this is not right. Second, trace, 5. Now I'm going to go to the next point, and I'm going to press enter, 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 and what I'll see is 7.43. I don't want that. I only want values between 0 and 6.28. So I've actually finished this problem. Okay, there it is. 1.15, 1.99, 4.29, and 5.13. I want you to try this second problem. Okay, plug in this into y1, plug in this into y2, then we're going to graph it, and then we're going to find the points of intersection by going to that second trace button to get calculate, 5 for intersect, and get close to those points. I'm going to show you here on the screen, but I want you to press pause and try it yourself. Okay? Alright. So again, I'm going to go back to y equals. I'm going to clear out everything I got, and I got to type in those two equations. So I'm going to type in on top, I'm going to go negative 2, not minus. Let me show you. Not minus. Negative button is right here. Okay. Negative 2 cosine of x, again, because theta is x is the same thing, and my parentheses, go down, and I'm going to type in 1.2. Now I got my two equations. I'm going to press graph. It's going to graph them for me. It's going to obviously do one equation at a time. It's doing the curve. Then it's doing the straight line, and again, second trace, 5 for intersection. Get close to that point. Right there, I'm close to it. Enter, enter, enter. 2.21. Let's write that. 2.21. There's my first point. Let's second trace again. 5 for intersection again. Get close to the next point. Enter, enter, enter. 4.07. And again, second trace, 5. I'm going to keep going here. Now here's what I want you to recognize. I'm trying to get over here, right? But right there, 6.38 is further than I want to go. I only want to go to 6.28. So I don't need to find that one way over here. I've already found my answer. Sometimes there's 2, sometimes there's 4, sometimes there's 8, sometimes there's 0. Sometimes there's even 1. But for this problem, there's only 2 points of intersection. That's the answer. Okay? And that, ladies and gentlemen, is it. The next 2 pages are your homework. Okay? Again, everything that is in the homework is right within this set of notes. Make sure that you're looking at what you need to do. At the very end, okay, actually I need to talk about 7 and 8 real quick. On 7 and 8, move this down a little bit, sorry. On 7 and 8, zoom it back out too. Oops, wrong way. Getting used to the zoom button here. On 7 and 8, it says find the period and amplitude, okay? What I would need you to do here is everything that we've been doing, okay? It says find the period and amplitude, okay? It also says the maximum and minimum values and the zeros. So there's a lot to do here. You're going to find the zeros. Maybe we should write that here, okay? For both of these. And write those in zeros, remember, are just where it crosses the x-axis. But again, I only need it from 0 to 2. So really, anything past this point, I don't care about all that. Anything past this point, I don't care about all that. Okay? So my zeros are right there and right there. You can write those in, try and figure out what they are. Then I also need to find my amplitude. I also need to find my period. And then I need to find my maximums and minimums. And there is going to be more than a few of them. So my maximums here, well, are again just from 0 to 2 pi. So where is a maximum? Well, there's a maximum right there at pi. There's another one at 3 pi, but I don't care. It's only from 0 to 2 pi. It says right in the directions. My minimums are the lowest points of the graphs, which occur at 0 and at 2 pi. And that's how we do maximum and minimums. Everything else you should be able to do. The zeros are right here. Well, halfway between pi and 0 is pi over 2. Halfway between pi and 2 pi, if you look at your unit circle, is 3 pi over 2. So now I've kind of already set up number 7 for you. You should be able to do number 8 from there. Okay? Just check my notes here to make sure if there's anything else I need to talk to you. 9 through 14 first. I would, if I were you, because you're still in this room, I would start with 9 through 14. We just got done with these types of problems in class, just to make sure that you got it and that you can do it from there. The rest of the questions, you can work your way through. You can do this all, I promise. We are going to do this the next day, though. You don't have to do it for homework tonight. We're going to do it in class tomorrow. Have a good day.